Picture a landscape so alien, it feels like another planet. Air stings your lungs, the ground bubbles with toxic colors, and heat distorts the horizon. This is the Danakil Depression, a real place in Ethiopia, where Earth's raw power is on full display. Here, temperatures soar, water vanishes instantly, and the land hisses with toxic gases and boiling pools. Scientists flock to this natural laboratory, drawn by its extremes and the mysteries it holds. For others, it's a glimpse into a mythic underworld, beautiful, terrifying, and utterly unique. Locals call it the gateway to hell, a name born from the Danakil's relentless danger and hypnotic beauty. The air reeks of sulfur, the ground glows with toxic minerals, and every step is a risk. One misstep can mean disaster. Boiling acid pools and poisonous vents lurk beneath a fragile crust. Yet the Danakil's chaos is mesmerizing, a place where beauty and terror collide. It challenges our sense of what's beautiful, forcing us to find awe in the nightmare. That's the Danakil's paradox. It repels and attracts, daring us to look closer. The Danakil Depression is one of Africa's lowest points, over 100 meters below sea level, and among the hottest places on Earth. It sits atop a tectonic triple junction, where three plates pull apart, tearing the land and birthing new oceans over millennia. Magma lurks just below the surface, fueling boiling springs, acidic pools, and toxic fumaroles. The result? A landscape of salt flats, sulfur fields, and mineral lakes, hostile to life yet geologically spectacular. Here, the rules of nature bend and the limits of geology and biology are pushed to the extreme. The Danakil is a living canvas of Earth's most primal forces. Amid this chaos, scientists made a shocking discovery. Life exists here. Extremophiles, microbes that thrive in acid, heat, and toxic brine, defy everything we thought we knew about survival. Their existence expands our idea of where life can flourish, on Earth and beyond. The Danakil isn't just a geological marvel, it's a portal to understanding life's true resilience. How do these organisms survive? What secrets do they hold about life's origins? The Danakil's greatest mystery isn't its violence, but the life that endures within it. Entering the Danakil is crossing into another world, one shaped by ancient forces and untouched by time. The journey is grueling, rough tracks, relentless heat, and a descent into a sunken, superheated basin. Here, rain is rare, the sun is merciless, and the landscape feels frozen in prehistory. The Danakil's isolation preserves its raw, primordial character, a living window into Earth's violent beginnings. To visit is to witness the planet's formative chaos, where life's limits are tested daily. The Danakil Depression, a journey to the edge of what's possible, and a glimpse into Earth's fiery heart. The first thing that strikes you upon arrival is not a sight, but a feeling. The oppressive weight and texture of the air itself. It is thick, heavy, and carries a heat that is almost liquid in its intensity. Breathing feels different here. Each inhalation is a conscious effort, drawing in air that feels searingly dry and laden with a faint metallic tang. During the dry season, which dominates the calendar year, temperatures in the Danakil Depression regularly exceed 45 degrees Celsius, or 113 degrees Fahrenheit. This is not the peak temperature of a brief heat wave, but the daily norm. a baseline condition of existence in this furnace-like environment. The heat is not just in the air, it radiates from every surface. Under the relentless glare of the sun, the world transforms. The air shimmers constantly, creating a perpetual mirage that distorts the horizon and makes distances impossible to judge. Solid objects appear to waver and melt into the landscape, adding to the disorienting, dreamlike quality of the place. Metal left exposed to the sun becomes a hazard, burning to the touch within minutes. A simple tool, a camera body, or the door of a vehicle can become a source of intense pain if handled carelessly. This pervasive, inescapable heat dictates the rhythm of all activity. Movement is slow and deliberate, and every action is calculated to conserve energy and avoid the sun's most punishing rays. Water, the most essential element for life, behaves erratically here. It is a precious, fleeting commodity that vanishes almost as soon as it appears. A bottle of water left open will see its contents rapidly diminish, not through drinking, but through sheer evaporation into the parched atmosphere. Spill a few drops on the ground, and they sizzle and disappear in seconds, leaving behind not even a trace of moisture. This extreme aridity makes survival a constant challenge, a battle against a climate that seems determined to draw every last drop of moisture from any living thing. The land is perpetually thirsty, a vast, cracked expanse defined by the absolute absence of water. But the heat is only the beginning of the story. It is the most immediate and obvious challenge, the first barrier that any visitor must confront. However, it is merely a symptom of a much larger and more powerful force at play. The scorching temperatures are a surface-level expression of the immense geological turmoil that defines the Danakil Depression. The real story of this place, the source of its extreme nature and its otherworldly landscapes, lies deeper. It is written in the very bedrock of the continent, in the slow, inexorable movement of tectonic plates that are tearing this part of the world apart. From below, the furnace is not just heated from above, but from within. Beneath the cracked and sun-scorched surface of the Danakil Depression lies a scene of geological violence on a planetary scale. This region is one of the most tectonically active places on Earth, situated at what geologists call a triple junction. It is the precise point where three massive sections of the Earth's crust, the African plate, the Arabian plate, and the Somali plate, are all moving away from each other. Imagine a piece of fabric being pulled in three different directions at once. Eventually, it will begin to stretch, thin, and tear. This is exactly what is happening to the continent of Africa here, in super slow motion, over a timescale of millions of years. The Great East African Rift Valley, a massive tear in the continent that runs for thousands of kilometers, finds its northernmost expression here in the Danakil. The process of rifting is relentless. The Arabian plate is pulling away from Africa to the northeast, creating the Red Sea and the Gulf of Aden. Simultaneously, the Somali plate is breaking away from the larger African plate, also known as the Nubian plate, along the Rift Valley. The Danakil Depression sits at the nexus of all this movement, a triangular block of crust that is sinking as the land on all sides pulls away. This region is, quite literally, tearing itself open, a process that will one day flood this desert and create a new ocean. This constant stretching has profound consequences for the landscape. It thins the Earth's crust, reducing the distance between the surface and the molten mantle below. In most parts of the world, The crust is tens of kilometers thick, providing a stable and insulating barrier from the planet's fiery interior. Here in the Danakil, the crust is stretched so thin that magma can exist just a few kilometers beneath your feet. This proximity to the planet's internal heat engine is the primary driver for the region's extreme volcanism and the bizarre hydrothermal features that make it famous. The ground is unstable, riddled with faults and fissures that act as conduits for heat and gas to escape from below. The entire landscape is a testament to this ongoing tectonic war. The ground is scarred with deep cracks, some hundreds of meters long, evidence of the immense strain on the crust. Frequent earthquakes shake the region, most too small to be felt by humans, but they are a constant reminder of the titanic forces at work. The Danakil Depression is not a static place, it is a dynamic, living, geological laboratory. Standing here, you are a witness to the fundamental processes of plate tectonics, the same forces that have shaped and reshaped the continents over billions of years. You are standing on what is, geologically speaking, brand new ground. The true architects of the Danakil's alien vistas are these unseen tectonic forces. The pulling apart of the plates creates a landscape that is constantly in flux, a canvas that is perpetually being repainted by geological processes. As the crust thins and fractures, it creates pathways for magma to rise towards the surface. While some of this magma erupts to form volcanoes, much of it remains trapped just below the ground, creating vast superheated chambers. These magma chambers act like giant burners on a stove, heating the rock and any groundwater that seeps down through the cracks in the crust. This is the engine that powers the Danakil's otherworldly hydrothermal systems. The water, heated to extreme temperatures, becomes a powerful solvent. As it circulates through the hot rock, it dissolves a rich cocktail of minerals and chemicals. It becomes saturated with sulfur, iron, salt, and a host of other compounds, transforming into a potent, superheated brine. This mineral-laden water is then forced back up towards the surface under immense pressure, emerging through fissures and vents in the earth. As it reaches the cooler air, the dissolved minerals precipitate out, crystallizing and depositing themselves on the ground. It is this process that paints the landscape with its astonishing palette of colors. The brilliant, almost fluorescent yellows are pure sulfur, precipitating directly from volcanic gases or from the acidic water. The rusty reds and oranges are the result of iron oxides formed as iron-rich fluids react with the oxygen in the atmosphere. The startling greens are often caused by copper salts, while the vast, blindingly white expanses are salt flats, left behind as ancient seas and saline lakes evaporated under the intense sun over thousands of years. These are not colors applied to the landscape, they are the landscape itself. Each hue tells a story of chemistry and geology, a visible record of the chemical reactions taking place between the planet's interior and its surface. This constant deposition of minerals builds up fantastic and fragile structures. Chimneys of sulfur, known as fumaroles, grow around gas vents, puffing out plumes of toxic steam. Terraced pools form like surreal infinity pools, their rims built up layer by layer from the minerals left behind by overflowing hot springs. The ground becomes a delicate, hollow crust in many places, with bubbling, acidic water just beneath. The entire hydrothermal field is a living, breathing system, changing day by day as new vents open up and old ones die down. The unseen forces below are engaged in a constant act of creation and destruction, sculpting a world that is as ephemeral as it is beautiful. The visual experience of the Danakil Depression is dominated by the Shimmering Mirage, an optical phenomenon born from the extreme heat. The air closest to the ground becomes superheated, causing its density to drop significantly compared to the slightly cooler air just a few feet above. This sharp temperature gradient bends light rays as they travel towards the observer, creating distorted and displaced images of distant objects. The effect is most profound across the vast flat salt plains. The distant horizon appears to ripple and dance, while mountains and rock formations seem to float in the air, detached from the ground by a shimmering layer that looks exactly like a body of water. This illusion is both beautiful and deeply disorienting. It plays tricks on the mind, making it incredibly difficult to perceive the landscape accurately. A small rock in the middle distance can appear to be a large hill far away, while a distant camel caravan might seem to be walking on the surface of a phantom lake. For travelers, especially those navigating on foot or by traditional means, this effect can be perilous, leading to misjudgments of distance and direction. The shimmering air erases the certainty of the horizon, blurring the line between the sky and the land, and immersing you in a world that feels unstable and fluid, as if reality itself is melting under the heat. This constant wavering of light contributes to the furnace-like feeling of the environment. It is a visible manifestation of the energy being radiated from the ground. You are not just feeling the heat, you are seeing it. The shimmering air is a constant reminder of the immense thermal load the landscape is under. It amplifies the sense of being in an oven, where every particle of air is vibrating with heat. This visual distortion, combined with the extreme temperatures and the stark emptiness of the landscape, creates a powerful psychological effect, isolating you in a world that seems to operate by its own surreal and unforgiving logic. But the mirage is more than just a trick of the light. It is a symbol of the Danakil's deceptive nature. From a distance, the landscape can appear serene, even beautiful, with its illusory lakes and vibrant colors. Yet, up close, it reveals itself to be a place of immense danger, filled with acidic pools, toxic gases, and unstable ground. The mirage mirrors this duality perfectly. It promises water where there is only desiccated salt, and presents a solid horizon that dissolves into a wavering illusion upon closer inspection. It teaches a crucial lesson for survival here. Nothing in the Danakil Depression is quite what it seems. While the daily changes in the Danakil Depression can be subtle, the overarching truth is that this is a land in a state of perpetual motion. The geological clock here ticks faster than in most other places on Earth. The ground beneath your feet is not a fixed, permanent stage, but an active participant in an ongoing drama. The separation of the tectonic plates, though measured in just a few centimeters per year, accumulates over centuries and millennia to produce dramatic and transformative change. This is one of the few places on the planet where you can stand and consciously feel that you are on a piece of crust that is actively being stretched, stressed, and broken. This motion manifests in countless ways. The frequent small-scale earthquakes are the most direct evidence, the sudden jolts and tremors of the crust adjusting to the immense strain. New fissures and cracks can open up overnight, venting steam and gas from deep within the earth. The hydrothermal fields are particularly dynamic. A pool that was bubbling with activity one year might be dry and silent the next, while a new spring may burst forth from a previously barren patch of ground. The landscape is constantly rewriting itself, driven by the restless plumbing system of magma and superheated water that snakes beneath the surface. This continuous movement means that the Danakil depression is a living, breathing entity. It is not a static relic of a past geological age, but a vibrant and active example of planetary processes at work today. Scientists who study the region are not just observing a landscape, they are observing a process. They use GPS sensors to measure the infinitesimally small movements of the plates, seismometers to record the tremors of the Earth, and chemical analysis to track the changes in the hydrothermal fluids. They are, in effect, taking the pulse of a planet in the act of forming a new ocean basin, gaining invaluable insights into the forces that have shaped our world. For any visitor, this sense of perpetual motion adds a final layer to the experience of being in the furnace. It is a profound reminder of the impermanence of even the most solid-seeming features of our world. Mountains rise and fall, continents drift, and oceans are born and die over geological time. Here in the Danakil, that vast timescale feels compressed and immediate. You are not just a spectator to an alien landscape. You are a witness to the raw, untamed power of a planet that is very much alive. The ground is not simply hot, it is moving, cracking, and transforming, a dynamic and volatile surface at the mercy of the immense forces churning within. As the tectonic plates continue their slow, inexorable separation, they do more than just stretch the land. They create a direct conduit between the planet's deep interior and its surface. This geological process is the master artist responsible for the Danakil's most striking feature, its unbelievable color palette. The ground here is not just rock and soil, it is a chemical canvas, stained with a spectrum of hues so intense and unnatural they seem to belong to another world entirely. These are not colors born of life, like the green of forests or the bloom of flowers. They are the stark elemental colors of raw chemistry, a direct visual representation of the minerals being dredged up from the Earth's mantle and deposited in the open air. The most dominant color is a startling, almost fluorescent yellow. This is the signature of sulfur, a key element in volcanic regions. It emerges in several forms, creating a varied and textured landscape. In some areas, it precipitates from hot, acidic water, forming delicate, crystalline structures that glitter in the harsh sunlight. In others, it is deposited directly from volcanic gases or fumaroles that vent from deep fissures in the ground. This gaseous sulfur coats the surrounding earth in a fine, bright yellow powder. The air itself is thick with the pungent, acrid smell of these sulfur compounds, a constant, unavoidable reminder of the volcanic processes unfolding just beneath your feet, a scent that defines the very atmosphere of this place. Contrasting with the brilliant yellows are deep, rusty oranges and rich, earthy reds. These hues are the work of iron. The superheated water circulating below the surface is rich in dissolved iron compounds. When this water emerges and comes into contact with the oxygen in the atmosphere, the iron oxidizes. It rusts. This process, happening on a massive scale, stains the ground in vast swathes of ochre, terracotta, and crimson. The patterns are fluid and organic, following the flow of the water, creating intricate river-like formations of color. It looks as though a giant has spilled pots of metallic paint across the desert, leaving behind a permanent record of the land's chemical bleeding. This elemental tapestry is completed by shocking splashes of acidic green and deep turquoise blues. These rarer colors are often indicators of other minerals, such as copper salts, which create vibrant verdigris tones when they precipitate out of the briny solutions. The interplay of all these chemicals, governed by the temperature, acidity, and flow of the hydrothermal springs, creates a landscape of breathtaking and surreal complexity. It is a place that defies all our preconceived notions of what a natural landscape should look like. The Danakil Depression is a stark, powerful illustration that the Earth, left to its own devices, can produce scenes of a beauty so alien and extreme, it feels as though it simply should not exist. At the very heart of the Danakil's chemical wonderland lies a place that pushes the boundaries of strangeness to their absolute limit. The Dalol hydrothermal field. This specific area is the crown jewel of the region's bizarre geology, a concentrated zone of the most intense and colorful activity. Dalol is, in fact, a volcanic explosion crater formed by an eruption in the year 1926. But it is not a typical volcano with a conical peak. Instead, it is a low-lying, sprawling complex of hot springs, acid pools, and gas vents, sitting more than 48 meters below sea level, making it the lowest subaerial volcanic vent in the world. This is the epicenter of the Danakil's weirdness. To walk through Dalol is to feel as though you have been transported to the surface of Jupiter's moon Io, renowned for its active sulfur volcanism. The landscape is a chaotic jumble of shapes and textures. Miniature salt canyons carved by acidic runoff snake through the fields of mineral deposits. Horn-like structures called fumaroles, built from crystallized sulfur and salt, jut out from the ground like alien growths, puffing out plumes of hot, toxic steam. The ground is a patchwork of fragile salt crusts, bubbling brine pools, and solid mineral formations, all painted in those impossibly vivid shades of yellow, green, and orange. The sheer density and variety of geological features packed into this one area is staggering. The landscape of Dalol is not static, it is alive and constantly changing. The hydrothermal system that feeds it is dynamic, with new springs emerging and old ones drying up on a daily or even hourly basis. A path that was safe to walk one day might be blocked by a newly formed boiling hot spring the next. The mineral structures themselves are ephemeral, growing and crumbling as the flow of water and gas shifts. This constant transformation gives the place a palpable sense of energy, as if you are witnessing a geological process in fast forward. It is a world being born and reborn before your very eyes, sculpted by forces of immense heat and chemical potency. This relentless activity makes Dalol one of the most visually spectacular and one of the most dangerous places on the planet. The beauty is inseparable from the peril. The vibrant colors are the direct result of toxic chemicals. The bubbling pools are filled with boiling acid, and the steaming vents release poisonous gases like hydrogen sulfide. It is a landscape that invites you in with its hypnotic beauty, while simultaneously warning you of its lethal nature. Dalol is the ultimate expression of the Danakil's paradox, a place of breathtaking allure that has been created by forces utterly hostile to life as we know it, a land that truly feels as if it shouldn't exist. Dotted throughout the hydrothermal fields of Dalol are features that look deceptively beautiful from a distance. Pools of water, shimmering with jewel-like colors. But these are not oases in the desert. They are pools of acid, cauldrons of boiling brine, and ponds of toxic chemicals. Some of the pools have a pH value that approaches 0, making them as acidic as battery acid. This extreme acidity is created when volcanic gases, particularly sulfur dioxide and hydrogen sulfide, mix with the hot water. The resulting solution is a powerful corrosive agent capable of dissolving minerals, rock, and any organic material that is unfortunate enough to fall into it. The colors of these pools are mesmerizing. Some are a startling, opaque green, their surfaces placid and milky. Others are a clear, vibrant turquoise, surrounded by delicate, lacy salt formations. These colors are a direct result of the unique chemical composition of each pool. The green may come from dissolved iron ions in a highly acidic, chloride-rich brine, while the turquoise hues can be created by copper salts. The water is often supersaturated with salt and other minerals, making it far denser than regular water. In some cases, the brine is so heavy that it can appear thick and oily, its surface barely rippling in the wind. The temperatures of these pools add another layer of extreme danger. Many are well above boiling point, heated from below by the magma that lies so close to the surface. The water, being a highly concentrated brine, has a boiling point much higher than that of fresh water. It can reach temperatures of up to 108 degrees Celsius, while remaining in a liquid state. The surface of these pools often churns and bubbles violently, not just from the heat, but from the constant release of volcanic gases from below. It is a witch's brew of heat, acid, and poison, a feature that embodies the term hell on Earth. To stand near these pools is a multi-sensory experience of extreme geology. You can feel the intense radiant heat on your skin, see the steam rising in thick clouds, and smell the sharp chemical odor that hangs in the air. You can hear the sinister gurgle and hiss of the bubbling liquid. These pools are a stark and visceral reminder of the raw power at play in the Danakil depression. They are not passive features of the landscape. They are active, dangerous vents connecting the surface world to the fiery, chemical-rich environment lurking just below the thin crust of the Earth. They are pockets of a subterranean world exposed for all to see. The dangers of the Danakil depression are not singular. They're a complex and interwoven tapestry of threats, a symphony of peril where, honestly, each element amplifies the others. The most immediate and obvious danger is the ground itself. In many areas, especially within the Dalol hydrothermal field, the solid-looking surface is a lie. It's merely a thin, fragile crust of salt and minerals formed over a hidden underworld of boiling mud, superheated brine, or empty cavities filled with toxic gas. One wrong step, one moment of misplaced confidence, and the ground can collapse beneath you, plunging you into a hellish environment from which, frankly, there is likely no escape. This treacherous terrain is made even more dangerous by the constant emission of invisible poisonous gases. The same fumaroles and fissures that paint the landscape with sulfur also release a cocktail of toxic compounds into the atmosphere. Hydrogen sulfide, with its characteristic rotten egg smell, is not just unpleasant. In high concentrations, it's a deadly respiratory poison that can paralyze the nervous system. Carbon dioxide, being denser than air, can accumulate in low-lying depressions, creating invisible pockets where oxygen is displaced. To venture into these areas without knowledge and caution is to risk asphyxiation, a silent and insidious death in this already hostile landscape. The acid is another pervasive threat. It's not just confined to the colorful pools. The steam that billows across the landscape is often highly acidic, and when it condenses, it can create a corrosive mist that irritates the eyes, skin, and respiratory tract. Over time, this acidic atmosphere takes its toll on everything. It corrodes metal, turning camera equipment and zippers into crumbling rust. It eats away at the fabric of clothing and the soles of shoes. This chemical assault is relentless and inescapable, a constant reminder that the very air you're breathing is actively working to unmake the world around you, including you. Compounding all these specific threats is the overwhelming, ever-present heat. The extreme temperatures cause rapid dehydration and increase the risk of heat stroke, impairing judgment and physical coordination. This makes navigating the already treacherous landscape even more difficult. A moment of dizziness or a lapse in concentration caused by the heat could easily lead to a fatal misstep. In the Danakil Depression, every element of the environment seems to conspire against survival. It's a place that demands constant vigilance, respect, and an acute awareness that you are a fragile visitor in a land that is fundamentally, chemically, and physically hostile to your existence. The concept of solid ground is one we, usually take for granted. It's the foundation of our world, the stage upon which our lives unfold. But in the Danakil Depression, this fundamental assumption is shattered. Here the ground is a fragile temporary crust, a delicate membrane separating our world from a subterranean realm of fire and brine. The process of mineral deposition that creates the stunning colors also results in a landscape that is hollow and unstable. As the hot, mineral-rich water flows and evaporates, it leaves behind layers of salt, sulfur, and other compounds, building up intricate but brittle formations over pockets of superheated liquid or gas. Walking across these areas is really an exercise in extreme caution. The ground often sounds hollow underfoot, and you can feel a slight vibration from the bubbling activity just inches below your boots. In some places, the crust is so thin that you can see the dark, boiling liquid through cracks and holes. Experienced guides who navigate these fields learn to read the landscape, identifying the subtle signs of danger. They look for differences in color, texture, and the thickness of the mineral deposits, knowing that a slight variation can mean the difference between a solid path and a catastrophic collapse. Every step is a calculated risk, a test of the ground's integrity. The fragility of this crust is a direct consequence of its rapid formation. Unlike rock, which is formed over millions of years under immense pressure, these mineral deposits are created quickly in a matter of days or weeks. They lack the structural integrity of true geological formations. They're constantly being built up in some places and dissolved away in others by the acidic waters. This creates a landscape that is in a state of constant, unpredictable flux. An area that was a thick, solid plain of salt one year might be a treacherous field of thin crusts and hidden pools the next, its underlying structure reconfigured by the shifting hydrothermal system. This inherent instability is one of the most unsettling aspects of the Danakil. It undermines our most basic sense of security and our trust in the world beneath our feet. The ground is not a dependable constant. It's a treacherous and deceptive surface. This feeling is a powerful metaphor for the Danakil Depression as a whole. It's a land that appears solid and real, but is in fact a thin veneer over a world of chaos and violence. It serves as a potent reminder that the stability we perceive in our own environments is a geological gift, not a guarantee, and that on a planetary scale we're all living on a fragile crust. In a land defined by bubbling pools and hot springs, it's a profound irony that the Danakil Depression is one of the driest places on Earth. The water that exists here is not the water of life. It's a geological agent, a chemical solvent. It's a brine so saturated with salt, acid, and toxic minerals that it's utterly undrinkable and hostile to almost all forms of life. The annual rainfall in this region is negligible, often amounting to less than 100 to 200 millimeters per year, and it evaporates almost as soon as it touches the superheated ground. The concept of fresh water, the cornerstone of life as we know it, is almost entirely absent. This profound aridity has shaped the landscape into a vast, desiccated wasteland. Beyond the immediate confines of the hydrothermal fields lie immense salt flats, the ghostly white remnants of ancient seas that once filled this depression. The largest of these is Lake Assel, which is not a lake of water but a seemingly endless expanse of solid, crystalline salt, in some places several kilometers thick. Under the relentless sun, the salt cracks into a mosaic of polygonal plates that stretch to the horizon. The blinding white glare reflected from the salt is almost as intense as the sun itself, creating a stark, minimalist landscape of overwhelming scale and emptiness. The absence of life-giving water means that there is virtually no vegetation. There are no trees to offer shade, no grasses to hold the soil, no plants to soften the harsh lines of the landscape. It's a world of rock, salt, and mineral dust. This lack of plant life contributes to the extreme temperatures, as there's no evapotranspiration to cool the air. The landscape is stripped bare, its geological bones exposed for all to see. The story of this land is not written in the growth rings of trees or the layers of soil, but in the strata of volcanic rock, the bands of evaporated minerals, and the deep fissures of a tearing continent. This world without water is the ultimate testament to the Danakil's extreme nature. It presents a fundamental paradox, a place that is geologically hyperactive but biologically almost sterile. It's a landscape where the primary constituent of life, water, is present but in a form that is utterly antithetical to it. This reality is what makes the Danakil feel so profoundly alien. It inverts our most basic understanding of the natural world, showing us that even the most fundamental elements can exist in states that are hostile and strange. It's a land that shouldn't exist because it defies the very logic of the habitable world we thought we knew. Not far from the kaleidoscopic chaos of the Dalol sulfur plains, the landscape shifts, rising from the profound depths of the depression into something even more primeval. The ground becomes darker, a field of jagged, black volcanic rock that stretches for miles. This is the domain of a different kind of geological giant. In the distance, a low, broad silhouette interrupts the flat horizon, its peak often shrouded in a hazy plume of smoke and gas. This is Erta Al, which in the local Afar language means the smoking mountain. It is not a dramatic conical peak like Kilimanjaro or Fuji, but a sprawling shield volcano built up over millennia by countless flows of fluid basaltic lava, its unassuming shape belying the furious power contained within. The journey to Erta Ale is a pilgrimage into a different circle of this terrestrial inferno. The terrain is brutal, a sea of sharp solidified lava flows, known as Pahoho and Aa. The former is smoother, with ropey textures, while the latter is a jumble of broken, clinker-like blocks with razor-sharp edges that can shred boots and tires with equal ease. To travel here is to cross a landscape that is geologically brand new, a world still cooling from its fiery birth. The black rock absorbs the intense desert sun, radiating heat upwards and creating an environment that feels even hotter than the salt flats below, if such a thing is possible. The air is filled with a faint sulfuric haze that signals the volcanic activity ahead. As night falls, the true nature of the smoking mountain is revealed. The subtle plume of smoke that is visible during the day transforms into a pulsating fiery glow against the dark sky. It is a beacon in the vast empty desert, a celestial blush that seems to emanate from the very heart of the earth. This otherworldly light is the reflection of molten rock, an incandescent beacon that has drawn travelers, scientists, and adventurers for decades. It is a promise of the spectacle that awaits at the summit, one of the rarest and most awe-inspiring natural phenomena on our planet. The glow is a constant living presence, a reminder that the volcano is not dormant but very much alive and breathing fire. The climb to the summit is typically undertaken in the relative cool of the night, guided by the faint starlight and the volcano's own infernal glow. The trek is arduous, a steady ascent over uneven, treacherous footing. With every step, the sense of anticipation builds, mixed with a primal apprehension. You are walking towards an open wound on the planet's surface, a place where the boundary between the solid world and the molten interior is completely erased. The distant rumble of the earth grows slightly louder. The air becomes thicker with volcanic gases, and the glow intensifies, painting the clouds above in shades of deep red and orange. You are approaching the rim of the world, preparing to gaze into its fiery soul. Reaching the crater rim of Ethiopia is a moment that transcends mere sight and sound. It is a full-body sensory immersion into the raw power of the planet. As you peer over the edge, the ground falls away into a vast, dark caldera, a crater within a crater, and there, at the bottom of this pit, is the sight you have traveled so far to witness. A churning, incandescent lake of molten rock. The heat hits you first, a physical wave that washes over your face and body, instantly drying your eyes and warming your skin. It's not like standing next to a bonfire. It is like opening the door to a planetary-sized furnace. The sheer thermal energy radiating from the lava lake is immense, a palpable force that commands respect and caution. The sounds are next, a deep and profoundly visceral symphony of the earth. There is a constant low-frequency rumbling that you feel in your chest as much as you hear with your ears. This is the sound of the planet's tectonic plates grinding and shifting, the deep bass note of geology itself. Layered over this is the sound of the lava lake itself, a continuous, sloshing sound, like a monstrous ocean surf, punctuated by the sharp crack and pop of bursting gas bubbles and the violent hiss of molten rock being flung into the air. It is a dynamic, living soundscape, the voice of a world in a constant state of creation, a noise that speaks of immense pressure and unimaginable heat. The smell is pungent and acrid, a thick cocktail of sulfur dioxide and other volcanic gases that billows up from the crater in waves. It stings the nostrils and can catch in the back of your throat, a chemical reminder of the toxic nature of this environment. The winds on the crater rim are fickle, and a sudden shift can engulf you in a thick, choking cloud of volcanic fumes, forcing you to retreat. This toxic breath of the volcano is a constant danger, another layer of peril that adds to the intensity of the experience. It reinforces the fact that you are an intruder here, a fragile, organic being in a realm of inorganic, elemental fury, sustained only by the whims of the wind. Standing there on the precipice, you feel an overwhelming sense of connection to the deep processes that govern our world. You are not just looking at a geological feature. You are looking at the very material from which planets are made. This is the same molten rock that forms new crust on the ocean floor and builds continents over millions of years. It feels like you are peering into the core of the Earth, witnessing the raw, untamed energy that lies hidden beneath our feet every day. The experience is humbling and profound, shrinking human concerns to insignificance in the face of such immense, timeless power. It is a direct, unfiltered encounter with the sublime. What makes the spectacle at Heart of so profoundly special is its rarity. A persistent, continuously active lava lake is one of the most uncommon geological phenomena on our planet. While many volcanoes have molten magma in chambers deep beneath them, only a handful in the entire world have a system stable enough to maintain a visible churning lake of lava at the surface for extended periods, often for decades or even centuries. As of today, only a few such lava lakes exist, including those at Mount Nyiragongo in the Congo, Mount Erebus in Antarctica, and here at Heart of in Ethiopia. To witness one is to see something that most people on Earth will never have the chance to experience. The existence of a permanent lava lake requires a delicate and improbable balance of geological conditions. There must be a constant and steady supply of magma from a deep reservoir, enough to replace the heat lost at the surface, but not so much that it causes a catastrophic eruption. The plumbing system of the volcano must be just right, with conduits that allow the magma to rise but also permit gases to escape without building up explosive pressure. The crater itself must have the right shape to contain the lake. Heart of volcanic system has achieved this perfect equilibrium, creating a stable window into the planet's mantle that has remained open for over a century. The surface of the lava lake is a mesmerizing and terrifying sight. It is not a placid pool of liquid, but a dynamic, ever-changing crust. As the molten rock at the surface is exposed to the cooler air, it begins to solidify, forming a thin, dark skin of basaltic rock. But the convection currents in the lake below are constantly in motion. Hotter, more buoyant lava from below rises up, tearing the dark crust apart. The crust fractures into plates that drift and collide, like miniature tectonic plates on a sea of fire. Where the crust is pulled apart, the incandescent, bright orange lava from beneath is revealed, creating brilliant lines of fire that crisscross the dark surface in a hypnotic, ever-shifting pattern. This constant process of crust formation, fracturing and sinking is known as lava lake tectonics. It is a stunning, small-scale model of the plate tectonic processes that shape the entire surface of our planet. Watching the dark plates of cooled lava collide, pull apart, and subduct back down into the molten depths is like watching the birth and death of continents in fast forward. If you're fascinated by the wonders of our planet, don't forget to subscribe for more incredible journeys. Hit the like button if you're enjoying the adventure, and share your thoughts or questions in the comments below. Your support helps us bring more amazing stories like this to you. The lava lake at Heart of is not just a geological curiosity, it is a natural laboratory. It provides scientists with a unique and accessible opportunity to study the behavior of magma and the fundamental dynamics of planetary crust formation in real time, offering insights that are impossible to gain anywhere else. The activity of the lava lake is not constant. It has a rhythm, a fiery heartbeat that pulses with the pressure from below. At times, the surface can be relatively calm, with the dark crust covering most of the lake, crisscrossed by a network of glowing cracks. Then, without warning, the activity can surge. Fountains of molten rock, driven by the explosive release of volcanic gases, can suddenly burst through the crust, flinging incandescent blobs of lava tens of meters into the air. These fiery displays, known as fountaining, are both beautiful and terrifying, a sudden escalation in the volcano's energy that demonstrates the immense power being held in check just below the surface. This pulsing activity is driven by the complex interplay of heat, pressure, and gas within the volcano's plumbing system. Gases like water vapor, carbon dioxide, and sulfur dioxide are dissolved in the magma deep within the earth. As the magma rises towards the surface and the pressure decreases, these gases come out of solution, forming bubbles. These bubbles coalesce and rise, and their violent escape at the surface is what powers the dramatic fountaining and churning of the lake. The lava lake acts as a giant degassing valve for the volcano, a safety mechanism that allows this pressure to be released relatively gently and continuously, rather than building up to a single catastrophic explosion. The temperature within the crater is almost beyond comprehension. The surface of the lava itself churns at temperatures exceeding 1,100 degrees Celsius, over 2,000 degrees Fahrenheit. The radiant heat is so intense that it can be felt hundreds of meters away on the crater rim. Standing near the edge feels like standing in front of an open blast furnace. This extreme thermal environment is a testament to the direct connection to the Earth's mantle, a place where the planet has not yet had time to cool down from its fiery formation billions of years ago. The lava lake is a raw, visceral manifestation of the internal heat that drives all of our planet's geological activity, from the slow drift of continents to the violent eruption of volcanoes. Observing this fiery heartbeat through the night is a hypnotic experience. The patterns of light and motion are constantly changing, never repeating. The lake breathes, swells, and bursts with energy, a living entity of rock and fire. It is a performance of geological time, a process that has been occurring here for decades and will likely continue for decades more. To watch it is to feel the pulse of the planet itself. It is a powerful reminder that beneath the cool, stable ground we live on, the Earth is a dynamic and molten world, a sphere of fire and energy, and that here at Erta Eile, the veil between our world and that one is at its thinnest. Despite the immense dangers, the extreme heat, the toxic gases, the unstable ground, and the risk of sudden eruption, Erta Eile draws human beings to its rim. We are a curious species, compelled to explore the edges of our world and to witness its most extreme expressions of power and beauty. The motivation for this intrusion is complex and varied. For scientists, the lava lake is an invaluable natural laboratory. It offers a unique window into magmatic processes, allowing them to study everything from the chemistry of volcanic gases to the physics of lava flows, providing crucial data that can help in understanding and predicting volcanic behavior elsewhere in the world. For adventurers and tourists, the appeal is more primal. It is the pursuit of the sublime, the desire to witness one of nature's most awesome and terrifying spectacles firsthand. It is the challenge of reaching a remote and difficult destination and the reward of a truly once-in-a-lifetime experience. The journey to Erta Eile is not for the faint of heart, and those who undertake it are often seeking to push their own boundaries, to step outside their comfort zones and connect with something elemental and wild. Standing on the crater rim, dwarfed by the scale of the volcano, is a profoundly humbling experience that puts our own lives and concerns into a new perspective. This human presence, however, raises profound questions. Why are we so drawn to these places of immense power and danger? Is it a desire to conquer nature, to stand at the edge of chaos and feel a sense of mastery? Or is it something deeper, a form of pilgrimage to connect with the fundamental forces that shaped our world and ultimately created us? The lava lake holds a mirror up to our own species, reflecting our courage and our foolishness, our scientific curiosity and our insatiable appetite for spectacle. The glowing heart of Erta becomes a focal point for some of our most fundamental human drives to explore, to understand, and to experience awe. And so, the question posed earlier in the desolate sulfur fields finds an echo here, at the lip of a volcano. Why do people travel here? Why do scientists study here? The answer is as complex as the landscape itself. We come because it is a place of ultimate reality, where the forces that govern the universe are on raw, unfiltered display. We come to learn about our planet, and in doing so, to learn about ourselves. The human intrusion into this fiery realm is a testament to our enduring need to confront the great mysteries of our world, even if it means traveling to the very gates of what many would call hell, just for a closer look. For all its geological grandeur and terrifying beauty, the most profound secret of the Danakil Depression was not written in rock or fire. It was hidden in plain sight, concealed within the bubbling acid pools and the scorching hot springs. For decades, the prevailing scientific consensus was clear. This place was sterile. The combination of extreme heat, hypersalinity, and dangerously low pH levels created an environment so toxic, so utterly hostile, that life simply could not exist. It was considered a terrestrial analogue for a world without biology, a place where chemistry and geology reigned supreme and unchallenged. But science is a process of questioning, of pushing boundaries. And a question lingered: was it truly, absolutely impossible? The search for an answer led to a discovery that was nothing short of revolutionary. In an environment that would dissolve human skin on contact, in water hot enough to boil and acidic enough to corrode metal, scientists found something incredible. They found life. Not complex life, not plants or animals, but something far more resilient: microorganisms. Tiny single-celled organisms, invisible to the naked eye, were found thriving in conditions that were previously thought to be the very definition of uninhabitable. This was not a case of life merely tolerating a harsh environment. This was life that had made a home in hell itself, a discovery that fundamentally challenged our understanding of biology. The initial findings were met with skepticism. Contamination is a constant risk in microbiology, and it was easy to assume that these microbes were simply stowaways, carried into the extreme environment on dust particles or research equipment, and not true inhabitants. But rigorous, repeated studies confirmed the impossible. The DNA extracted from the water samples belonged to organisms that were genuinely living and reproducing within the toxic brew of Dalol's springs. They were not just surviving, they were thriving. The chemical-rich waters that were considered a poison to all other life forms were, for these microbes, a life-giving soup, their source of energy and nourishment. This discovery was a seismic shock to the scientific world. It was the biological equivalent of finding a flower blooming in a furnace. The existence of these organisms forced a complete and radical re-evaluation of the absolute limits of life on our planet. The Danakil Depression was instantly transformed from a sterile geological curiosity into one of the most important biological sites on Earth. It became a living laboratory for understanding resilience, adaptation, and the sheer tenacity of life. The impossible had been proven possible, and the implications of this single discovery would ripple outwards, reaching far beyond the borders of this Ethiopian desert all the way to the stars. The organisms discovered in the Danakil Depression belong to a remarkable class of life known as extremophiles. The name, derived from Latin and Greek, literally means extreme lovers, and it perfectly encapsulates their nature. These are not organisms that have been reluctantly forced into a harsh environment. They have evolved over countless generations to specifically require these conditions for their survival. A temperate, neutral pH environment that we would consider paradise would be, for many of these microbes, a sterile and lethal desert. They have adapted so perfectly to their extreme niche that they cannot live anywhere else. Their home is the inferno, and they are its native inhabitants. These microbes are a diverse group primarily belonging to the domain of life known as archaea. This is an ancient branch on the tree of life, distinct from bacteria and from more complex organisms like plants and animals. Many archaea are known to be extremophils, found in deep-sea hydrothermal vents, volcanic hot springs, and other harsh environments. But the organisms in the Danakil push these known limits even further. They are what scientists call polyextremophiles, meaning they are adapted to thrive in multiple simultaneous extreme conditions. It's not just the heat or the acid or the salt. It's the deadly combination of all three at once. Consider the challenges they overcome. The extreme heat, often above boiling point, would normally cause the proteins and DNA of a living cell to denature or fall apart, rendering them useless. But these microbes have evolved unique, incredibly stable enzymes and cellular structures that can withstand these temperatures. The intense acidity would typically destroy a cell's outer membrane, causing it to dissolve. Yet these organisms possess specialized membranes that can maintain their integrity in a bath of acid. The hypersaline water would ordinarily suck the moisture out of a cell through osmosis, desiccating it completely. But these extremophils have developed ways to manage their internal salt concentration, preventing this fatal water loss. In essence, these tiny life forms are master chemists and engineers. They have evolved sophisticated biochemical machinery that allows them to navigate a world that is, to us, a chemical war zone. They metabolize sulfur, iron, and other minerals, drawing energy from chemical reactions that are alien to our own biology. They have turned poison into food and have built a thriving ecosystem in a place where no ecosystem was thought possible. The discovery of these polyextremophiles in the Danakil Depression revealed a whole new dimension to life's adaptability, a testament to its relentless ability to find a way, no matter how hostile the surrounding. The survival of these microorganisms in the Danakil's cauldron is a story of incredible biochemical innovation. Their entire cellular structure is a fortress designed to withstand a constant, multi-pronged assault from the environment. Their cell membranes, the delicate skins that separate the inside of the cell from the outside world, are fundamentally different from our own. They are constructed from unique lipid molecules that form stronger, more stable bonds, preventing them from disintegrating in the extreme heat and acid. This specialized membrane is their first and most critical line of defense, a shield against the corrosive world they inhabit. Inside the cell, another set of marvels is at work. The proteins that carry out all the essential functions of life, the enzymes that catalyze reactions, the structural proteins that give the cell its shape, are hyperstabilized. They are folded into more compact, rigid shapes, reinforced by extra chemical bonds that prevent them from unraveling in the heat. Furthermore, the cells produce special chaperone proteins whose sole job is to find any proteins that have been damaged by the heat and refold them into their correct, functional shape. It is a constant internal process of damage control and repair, a biological maintenance crew working tirelessly to keep the cellular machinery running. To combat the intense salinity, these microbes employ a clever strategy. To prevent water from being drawn out of their cells by osmosis, they must make the inside of their cell just as salty or even saltier than the outside world. They actively pump salt ions into their cytoplasm, or they synthesize vast quantities of small organic molecules. This balances the osmotic pressure, preventing dehydration. This means that the internal environment of these cells is itself an extreme chemical brew that would be toxic to most other forms of life. Their entire biology, from the outside in, is calibrated to operate within this high-salt, high-temperature context. Perhaps most remarkably, they have learned to eat what would kill us. Instead of using sunlight for photosynthesis or consuming organic matter, many of these microbes are chemoautotrophs. They derive their energy from purely inorganic chemical reactions. They can breathe iron or sulfur in the same way we breathe oxygen, metabolizing the rich mineral soup of the hot springs to power their existence. They are living directly off the geology of the planet. This metabolic ingenuity is what allows a complex ecosystem to exist in a place with no sunlight penetrating the murky pools and no other life forms to eat. They are the foundation of a food web based not on biology, but on raw chemistry. The discovery of a thriving microbial community in the Danakil hydrothermal fields was more than just a scientific curiosity. It was a profound shock to the system of astrobiology. For decades, scientists searching for life on other planets, astrobiologists, had operated on a set of assumptions about what constitutes a habitable environment. These assumptions were largely based on the conditions required for life as we knew it: the presence of liquid water, moderate temperatures, and a relatively neutral pH. The Danakil Depression, with its boiling acid and toxic brine, was a place that failed this test spectacularly. It was the poster child for an uninhabitable world, and yet, here was life. This single data point from our own planet forced a dramatic and immediate expansion of the very definition of habitability. If life could exist in the Danakil, then the range of possible environments that could support life elsewhere in the universe was suddenly vastly larger than previously imagined. Worlds that had been dismissed as too hot, too acidic, or too toxic were now back on the table as potential abodes for life. The discovery fundamentally shifted the goalposts, forcing scientists to think more creatively and to look for life in places they had once written off entirely. The implications were electrifying. It suggested that life might not be a fragile, delicate fluke that requires perfect Earth-like conditions to emerge and survive. Instead, it might be a robust, tenacious, and chemically opportunistic force that can take hold wherever there is a source of energy and a liquid medium, no matter how extreme. The extremophiles of Danakil are a powerful argument that life adapts to the geochemistry of a planet, not the other way around. They show us that biology can be far more flexible and inventive than we ever gave it credit for, capable of solving environmental challenges that seem insurmountable to us. This paradigm shift has had a direct impact on how we explore our own solar system. When NASA's rovers hunt for signs of past life on Mars, or when probes are designed to explore the subsurface oceans of moons like Europa and Enceladus, the lessons from the Danakil are at the forefront of scientists' minds. They are no longer just looking for fossils in benign ancient lake beds. They are also searching for the chemical signatures of extremophile life in ancient hydrothermal vent systems, places that might have resembled Dalol billions of years ago. The discovery of life in hell on Earth has given us new hope and a new roadmap for finding life elsewhere. Ultimately, the microorganisms of the Danakil Depression force us to confront one of the most fundamental questions in all of science: what is life? We often define it by what we see around us: plants, animals, the familiar biology of a temperate world. But the extremophiles show us that this is a profoundly limited and biased perspective. They represent a different kind of life, one that operates by a set of rules so alien to our own that it challenges our very definitions. They demonstrate that the line between a living organism and a complex chemical reaction can be blurry, and that life is, at its core, a process of harnessing energy to create order out of chaos. The existence of these microbes suggests that the so-called habitable zone around a star, the narrow band where liquid water can exist on a planet's surface, might be too restrictive a concept. The Danakil shows us that habitable zones can exist in pockets, independent of the surface conditions. A planet or moon that is frozen on the outside could harbor life deep below its surface, warmed by tidal forces or radioactive decay, creating hydrothermal systems not unlike those in Ethiopia. Life doesn't necessarily need the gentle warmth of a sun. It can be powered by the internal heat of a planet itself. This opens up countless new worlds in our own solar system and beyond as potential candidates for life. Furthermore, the Danakil provides a compelling glimpse into what the very first life on our own planet might have looked like. Billions of years ago, early Earth was a much more violent and extreme place than it is today. The atmosphere was toxic, volcanic activity was rampant, and the planet was bombarded by asteroids. It is highly probable that life did not begin in a calm, gentle pond, but in a harsh, dynamic environment rich in chemical energy, a place very much like the Danakil Depression. The extremophiles living there today may be the closest modern relatives we have to our own most ancient ancestors, a window into our planet's biological dawn. And so, this landscape of death and fire paradoxically becomes a symbol of life's indomitable persistence. It redefines the rules, showing us that our own biology is just one possible solution to the problem of existence. The discovery of life in hell is not just about finding tiny, strange microbes. It's about expanding our own imagination. It forces us to accept that life might be a fundamental property of the universe, a chemical imperative that will emerge and adapt in the most unlikely of places. The Danakil Depression, a land that shouldn't exist, is home to a form of life that shouldn't exist. And in doing so, it tells us that we have only just begun to understand what is possible. When space agencies like NASA and the ESA plan missions to search for life on Mars, their work does not begin on the launch pad. It begins in places like this. The Danakil Depression is considered by astrobiologists to be one of the most valuable Earth analogues for extraterrestrial environments, particularly for the planet Mars. An analog site is a location on our own world that shares key geological or chemical characteristics with a planetary body we wish to study. By studying these places, scientists can test their instruments, practice their exploration techniques, and, most importantly, learn what kinds of signatures alien life might leave behind in a similar environment. The Danakil is in many ways a piece of Mars on Earth. The connection is striking. Evidence gathered by rovers and orbiters strongly suggests that ancient Mars was a very different world than the cold, dry desert we see today. Billions of years ago, Mars had active volcanoes, a thicker atmosphere, and crucially, liquid water. It likely hosted vast hydrothermal systems, environments where volcanic heat from below interacted with water on or near the surface. These Martian hydrothermal systems would have been rich in the same kinds of minerals we see in the Danakil today: sulfur, iron oxides, and salt deposits. The rusty red color of Mars is, after all, due to the prevalence of iron oxides, the same compounds that paint parts of the Danakil in deep oranges and reds. By studying the unique chemical fingerprints left behind by the extremophiles in the Danakil, scientists can develop a search pattern for life on Mars. They are not looking for little green men. They are looking for biosignatures. These could be specific types of minerals that are known to be formed or altered by microbial activity, or particular organic molecules that are unlikely to be created by geology alone. The Danakil provides a perfect testing ground. Scientists can analyze a rock, find the chemical trace of a microbe, and then say, this is what we need to look for on Mars. It allows them to fine-tune the sensitive instruments aboard rovers like Perseverance, programming them to spot the subtle, telltale signs of life in an alien rock. Therefore, every sample taken from a boiling acid pool, every analysis of a sulfur deposit, and every genetic sequence of a Danakil microbe is not just a lesson about our own planet. It is a dress rehearsal for one of the most profound quests in human history, the search for extraterrestrial life. The desolate alien landscape of this Ethiopian desert has become an indispensable training ground for exploring other worlds. When we send our robotic emissaries to sift through the red dust of Mars, they carry with them the knowledge hard-won from this terrestrial hell. The Danakil Depression is our Rosetta Stone for translating the language of Martian geology and searching for the signature of life. The Danakil Depression does not just offer a portal to other planets. It also provides a tantalizing window into our own planet's deep, tumultuous past. The Earth we know today, with its blue oceans, green continents, and oxygen-rich atmosphere, is a gentle anomaly. For the first few billion years of its existence, our world was a much more violent and extreme place. The early Earth was a planet of fire and brimstone, its surface covered in volcanoes, its atmosphere thick with toxic gases like methane and ammonia, and its nascent oceans likely far more acidic and saline than they are today. It was a world that would have looked, sounded, and smelled remarkably like the Danakil Depression. It is into this harsh, primordial crucible that life first emerged. The oldest fossils ever discovered are of microscopic organisms that lived around 3.5 billion years ago, and they are found in rock formations that suggest an ancient hydrothermal environment. This has led many scientists to favor the iron-sulfur world hypothesis for the origin of life. This theory proposes that life did not begin in a calm, sunlit pond, as Darwin once mused, but in the dark, energy-rich environment of deep-sea hydrothermal vents, or terrestrial hot springs. These places would have provided the three key ingredients for life: a liquid medium, a source of chemical energy, and a rich supply of organic building blocks. The Danakil Depression is a living, breathing model of such a world. The chemo-autotrophic microbes that thrive here, deriving their energy from inorganic chemicals like sulfur and iron, are a modern analogue for what our own most ancient ancestors might have been like. They demonstrate that a complex ecosystem can be built entirely on geological energy, without any need for sunlight. By studying the metabolic pathways of these Danakil extremophiles, scientists can work backwards, piecing together the likely biochemistry of the very first life forms. These tiny organisms are like living fossils, carrying in their DNA the echoes of a time when the entire planet was an extreme environment. This raises a profound and humbling question. Did all life on Earth, including us, begin in a place like this? Is the foundation of our own existence rooted in a hellish landscape of acid, heat, and poison? The evidence increasingly suggests that the answer may be yes. Our distant family tree does not begin in a garden, but in a furnace. The Danakil Depression, therefore, is more than just an alien landscape. It is our own ancestral home, a preserved fragment of the world that gave birth to the first spark of life. To stand here is to stand at the cradle of biology, witnessing the same conditions that allowed our planet to transform from a sterile rock into a living world. The alien connection forged in the Danakil Depression fuels one of the most compelling questions humanity can ask. Are we alone in the universe? The discovery of extremophiles here on Earth has radically reshaped the search for an answer. By proving that life can thrive in conditions we once thought were sterilizing, it dramatically increases the number of potential habitats in our own solar system and beyond. The search is no longer just for Earth-like planets, but for any world that possesses the two most fundamental ingredients, a source of energy and a liquid solvent, most likely water. The Danakil teaches us that where these two things exist, life might just find a way. This new perspective directs our attention to some of the most intriguing worlds in our cosmic neighborhood. Consider Europa, a moon of Jupiter, or Enceladus, a moon of Saturn. Both are covered in a thick shell of ice, but gravitational forces from their parent planets likely churn their interiors, generating enough heat to maintain vast liquid water oceans beneath the frozen crust. At the floor of these alien oceans, it is highly probable that hydrothermal vents exist, spewing out heat and chemical nutrients into the dark water. These environments could be remarkably similar to the hydrothermal systems of the Danakil, providing a perfect, protected cradle for a second genesis, the independent origin of life. The lessons from Danakil are critical for designing missions to explore these ocean worlds. We now know that life might not be floating in the open ocean, but concentrated around these geologically active hotspots. Future probes could be designed to land near cracks in the ice, where ocean water may be venting into space, sniffing the plumes for the chemical biosignatures of life. Or, more ambitiously, a future submersible could one day melt its way through the ice shell and swim down to the ocean floor, its headlights searching for the shimmering heat and mineral chimneys of a hydrothermal vent, just as a scientist explores the fields of Dalol. The search strategy is a direct import from what we've learned in Ethiopia. The ultimate goal is to find life that is not related to us, life that represents a completely separate origin. Such a discovery would be the single most profound in the history of science. It would tell us that life is not a unique miracle that happened once on Earth, but a common, perhaps even inevitable, outcome of planetary chemistry. It would mean that the universe is teeming with biology and that we are part of a vast cosmic community. The tiny, resilient microbes of the Danakil Depression are the vanguard of this search. They are the proof of concept that gives us hope that a second Genesis is not just a fantasy but a real possibility waiting to be discovered. Ultimately, the Danakil Depression acts as a mirror, reflecting not only our planet's past, but also the potential future of our discoveries on other worlds. This landscape forces us to shed our Earth-centric biases and to think more broadly about what life is and where it could be found. For centuries, our imagination about alien life was constrained by our own biology. We imagined creatures that needed oxygen, moderate temperatures, and sunlight. The Danakil shatters this mirror and replaces it with a prism, showing us that life can refract into a spectrum of incredible and unexpected forms, each perfectly adapted to its own unique and often brutal environment. This perspective is crucial as we begin to analyze the atmospheres of exoplanets, planets orbiting other stars. Using powerful telescopes like the James Webb Space Telescope, we can now study the chemical composition of distant worlds. We look for gases like oxygen and methane as potential signs of life. But what if an alien biosphere is based on a different chemistry? What if it's a world like the Danakil, where the dominant metabolic process involves sulfur? Its atmosphere might be rich in gases like hydrogen sulfide. Without the analogue of the Danakil, we might dismiss such a world as a toxic wasteland, when in fact we could be looking at a planet teeming with extremophile life. The Danakil also teaches us about the appearance of life. When we look for life, we should not just be looking for green. On a distant planet, a landscape covered in photosynthesizing organisms might not be green at all, but red, black, or purple, depending on the type of star it orbits and the specific pigments its life has evolved. And, in a world powered by geochemistry instead of starlight, the most vibrant signs of life might be the mineral stains on the ground, the brilliant yellows, oranges, and greens left behind by microbial colonies metabolizing the rock itself. The Danakil shows us that the most colorful and obvious sign of life on a planet might not be biological in form, but geological in expression. And so, this alien landscape on Earth completes its final and most important role. It serves as an essential tool for expanding our cosmic imagination. It challenges us, provokes us, and prepares us for the sheer strangeness that we might one day find when we finally encounter life beyond our own world. The Danakil Depression is a stark and beautiful reminder that the universe is likely far more creative and resilient than we think. It tells us that to find the alien, we must first be willing to understand the extreme, and that sometimes the greatest clues to what lies out there can be found right here, in the most unlikely corners of our own incredible planet. Despite its brutal, otherworldly nature, the Danakil Depression is not an empty wilderness. It is a home. For centuries, this seemingly uninhabitable landscape has been the ancestral land of the Afar people, a semi-nomadic group whose resilience is as legendary as the harshness of their environment. While scientists and adventurers are mere visitors, temporary intruders in this extreme world, the Afar are its true inhabitants. They have not just learned to survive in the furnace, they have woven their entire culture and existence into its fabric. Their lives are a testament to the extraordinary adaptability and endurance of the human spirit, a story even more remarkable than that of the extremophile microbes. The Afar people have developed a deep, intimate knowledge of this perilous land, passed down through countless generations. They understand the subtle language of the desert, the direction of the wind, the meaning of a cloud formation, the safe paths across the treacherous salt flats. They navigate this world not with GPS, but with an inherited wisdom that is etched into their collective memory. Their connection to this place is not one of conquest or dominion, but of a hard-won, respectful coexistence. They know its dangers intimately, but they also know its resources. And for them, the most precious resource of all is not water, but salt. This land of fire and acid is also a land of salt. The vast, blindingly white plains of Lake Assail are a seemingly endless deposit of pure rock salt, the crystallized remains of an ancient sea. For the Afar, this salt is their gold, their currency, their reason for being in this unforgiving place. For centuries, they have been the masters of the salt trade, a vital economic artery that connects the desolate lowlands with the fertile highlands of Ethiopia. Their entire society and way of life have been built around the arduous, backbreaking work of mining this white gold from the hottest place on earth, a tradition that has remained largely unchanged for 1,000 years. To live here is to embody resilience. The Afar people have adapted, both culturally and perhaps even physiologically, to a life of extreme heat and scarcity. Their traditional homes are light, mobile structures designed for ventilation and easy relocation. Their diet is lean, and their understanding of water conservation is absolute. They are a proud and fiercely independent people, their character forged in the crucible of the Danakil. Their story is the missing piece of the puzzle, the human element in this alien landscape. It reminds us that this is not just a geological spectacle. It is a place of human struggle, history, and profound cultural significance. The heart of the Afar economy and, really the central drama of human life in the Danakil is the salt caravan. This ancient trade is a monumental undertaking, a process that operates entirely without the aid of modern machinery. It all begins at sunrise on the salt flats of Lake Assail, under a sun that is already beginning to beat down with punishing intensity. The miners set to work. Using rudimentary hand-forged tools, long poles and simple axes, they pry large slabs of salt from the cracked crystalline ground. The work is rhythmic and incredibly demanding, each movement a testament to strength and technique honed over a lifetime of labor in this extreme heat. Once the large slabs are levered from the ground, another team of workers, the cutters, takes over. With astonishing precision and speed, they use small, adze-like axes to chop and shape the rough slabs into uniform, rectangular tiles of a standard size and weight. These tiles, known locally as amali, were once the official currency of Ethiopia, used as a medium of exchange for centuries. Today, they are still a valuable commodity, primarily used for livestock and, in some rural areas, for human consumption. The air rings with the sharp, percussive sound of axes striking salt, a sound that has echoed across these flats for generations. The next stage of the journey belongs to the camels, Vast caravans, sometimes numbering in the hundreds, are assembled to transport the salt. Each camel is loaded with a carefully balanced stack of salt tiles, which can weigh up to 150 kilograms. These ships of the desert, perfectly adapted to the arid environment, are the lifeblood of the trade, the only viable means of transporting such heavy loads across the treacherous terrain. The caravan leaders, seasoned veterans of the salt routes, guide their animals across the scorching desert, a journey that can take days or even weeks to reach the markets in the highlands. This entire process is a living relic, really, a window into a past that has vanished from most of the world. It is a system built on human muscle, animal endurance, and an unbreakable tradition. There are no engines, no conveyor belts, no automated systems. It is a trade carried on the backs of men and beasts, powered by resilience and a deep understanding of the desert's rhythms. The salt caravan is more than just a commercial enterprise. It is a cultural institution, a ritual that binds the Afar people to their land and to their history. It is a moving, breathing monument to human survival in one of the planet's most challenging landscapes. For the men who work the salt mines, life is a daily battle against the elements. They often travel for days to reach the mining sites, where they live in temporary camps, exposed to the full fury of the Danakil's climate. Their workday begins before dawn to take advantage of the slightly less oppressive temperatures, but by mid-morning, the heat is already excruciating. There is no shade on the vast, reflective salt flats. The sun beats down from above, and its blinding glare reflects up from below, creating an oven-like environment where temperatures can soar above 50 degrees Celsius, 122 degrees Fahrenheit. Dehydration is a constant and life-threatening risk. The physical toll of this work is immense and is etched onto the bodies of the miners. Their hands are calloused and worn from the constant friction of their tools, and their skin is weathered and darkened by a lifetime under the relentless sun. The labor is punishing, requiring enormous physical strength to pry the heavy salt slabs from the earth and carry them to the cutters. The miners earn a meager wage for their efforts, a testament not to the value of their labor, but to the harsh economic realities of this remote region. For many, it is the only life they know, the only path available to support their families. Despite the incredible hardship, there is a profound sense of dignity and camaraderie among the workers. They work together in coordinated teams, their movements synchronized by years of shared experience. They share what little water and food they have, and they rely on each other for survival in this unforgiving place. There is a pride in their work, a pride in their ability to endure what few others could, and a pride in upholding a tradition that has defined their people for centuries. It is a brutal existence, but it is one that is infused with a deep sense of purpose and cultural identity. This life, carved from fire and salt, represents the ultimate human cost of the Danakil depression. It is a stark contrast to the scientific wonder and tourist spectacle that the region has become for outsiders. For the Afar miners, this is not an alien landscape to be marveled at. It is their workplace, their home, and their burden. Their story is one of raw human grit, a daily struggle for survival that is often invisible to those who come merely to see the colors of Dalol or the fire of Erta Eile. They are the human heart of this extreme world, and their story is one of the most powerful and humbling that the Danakil has to tell. The ancient and resilient way of life of the Afar people now faces a challenge that may be even greater than the timeless harshness of their environment: climate change. The Danakil Depression is already one of the hottest places on Earth, a region where life exists at the very edge of survivability. But global warming is pushing those limits even further. Scientists have observed that heat waves in the region are becoming more frequent, more intense and longer lasting. An already extreme place is becoming even more dangerous, threatening to make the traditional work of salt mining not just difficult, but honestly impossible. For the salt miners, this is not an abstract scientific concept, it is a lived reality. They report that the sun feels hotter than it did in their father's time, that the workdays are becoming more punishing, and that the risks of heat stroke and fatal dehydration are rising. A few degrees of increase in the average temperature may seem small, but in an environment that already pushes the human body to its absolute thermal limit, it can be the difference between survival and death. The delicate balance that has allowed the Afar to inhabit this land for centuries is being dangerously disrupted by a global phenomenon they had no hand in creating. The threat is not just from the heat. Climate change is also making weather patterns more erratic. While the Danakil is profoundly arid, changes in regional climate could lead to unseasonal and catastrophic flooding, which has occurred in the past, destroying mining operations and threatening the very existence of the salt plains. Furthermore, the slow encroachment of the modern world, including the construction of new asphalt roads, threatens the economic viability of the traditional camel caravans, as trucks become a faster and cheaper way to transport salt. The ancient trade that forms the bedrock of Afar culture is facing obsolescence. The human cost of the Danakil Depression is therefore entering a new and uncertain chapter. The Afar people, who have withstood the geological violence and chemical hostility of their homeland for millennia, now face a more insidious threat. Their story of resilience is becoming a story of vulnerability. They stand on the front lines of a changing planet, a community whose very existence is threatened by rising temperatures. The people of the salt, the ultimate survivors, are a poignant and powerful symbol of the human cost of a warming world, a warning sent from the hottest place on Earth. Our journey through the Danakil Depression comes to an end. But the echoes of its fiery landscapes and profound truths will linger long after we have retreated to the comfort of our familiar world. This place, in all its terrible beauty and scientific wonder, serves as a powerful and visceral warning from our planet. It is a stark reminder that the ground beneath our feet is not the static, dependable stage we often imagine it to be. The Earth is not stable. It is a living, breathing, and sometimes violent entity, a dynamic system of immense power that is constantly shifting, cracking, burning, and transforming itself in ways that are far beyond our control or comprehension. The Danakil Depression shows us this planetary vitality in its most raw and unfiltered form. Here, the forces that shape continents and forge oceans are not abstract geological concepts confined to textbooks. They are immediate, tangible realities. You can see the crust of the Earth being torn apart. You can feel the heat of its molten interior radiating from the ground. You can smell the chemical breath of its volcanic soul. This experience fundamentally challenges our perception of permanence. It reveals that the landscapes we consider timeless, our mountains, our coastlines, our valleys, are, in the grand scheme of geological time, merely temporary features, fleeting expressions of a planet in a constant state of flux. This inherent instability is not a threat to be feared, but a reality to be respected. The Danakil teaches us that what seems permanent is often temporary, and that the solid ground of our assumptions can crumble beneath us. The same forces that create the hypnotic beauty of Dalol and the awesome spectacle of Erta are at work, albeit more slowly and subtly, all across the globe. Our planet is always moving, its tectonic plates grinding against each other, building pressure that is released in earthquakes and volcanic eruptions. The Danakil is simply a place where the veil is thinner, where we are granted a rare and unsettling glimpse into the planet's restless, unstable heart. In an age where humanity seeks to control and engineer every aspect of our environment, the Danakil depression stands as a monument to the untamable. It is a lesson in humility, a powerful counterpoint to our own sense of importance and command. It reminds us that we are not masters of this world, but merely passengers on a dynamic and sometimes turbulent planetary vessel. The Earth was here long before us, a world of fire and rock, and it will continue its geological journey long after we are gone. The warning from the Danakil is clear. We must learn to live with respect for the immense and indifferent power of the planet we call home. Yet, for all its warnings of geological violence and instability, the Danakil depression offers another, equally powerful message. It is a message not of destruction, but of creation, not of death, but of life in its most tenacious and unexpected forms. The discovery of extremophile microbes thriving in the boiling acid and toxic brine of Dalol is one of the most profound biological revelations of our time. It is a testament to the sheer, stubborn, and utterly relentless will of life to exist. It demonstrates that life doesn't need comfort or gentleness to flourish. It needs only an opportunity, a source of energy, and the raw materials of chemistry. These tiny organisms, the true natives of this terrestrial hell, redefine the very boundaries of existence. They show us that life is not a fragile accident that requires perfect conditions, but a robust and adaptable force, capable of conquering the most hostile environments imaginable. Their survival is a masterclass in evolutionary innovation, a story of biochemical ingenuity that allows them to turn poison into sustenance and to build a home in a furnace. They are a living, breathing paradox, a symbol of life's profound resilience in a landscape that seems to embody death. Their existence transforms the Danakil from a mere geological wonder into a biological miracle. This message of tenacity is echoed in the human story of the Danakil. The Afar people who have carved a life from this brutal land for centuries are a testament to the endurance of the human spirit. Their resilience in the face of unimaginable hardship, the searing heat, the back-breaking labor, the constant threat of dehydration, mirrors the resilience of the microbes on a macroscopic scale. They too have adapted, not through biochemical innovation, but through cultural wisdom, physical toughness, and an unbreakable connection to their ancestral lands. Their story is a powerful reminder that adaptation is not just a biological process, but a human one as well. The Danakil depression, therefore, presents us with a profound duality. It is a place that looks utterly alien, yet it may represent something deeply fundamental about the nature of life itself, both on our world and potentially on others. It is a glimpse into Earth's fiery past, a preview of what we might find on other worlds, and a powerful reminder that life doesn't need our permission or our definition of comfort to exist. It adapts, it survives, it endures. Even in hell, life finds a way to carve out a kingdom for itself. A triumphant and inspiring message from the planet's most unforgiving corner. As we turn our gaze from the Danakil, we realize that this remote and alien landscape holds up a mirror, reflecting not just our planet's past, but also some of the most pressing challenges of our collective future. The story of the Afar people, whose ancient way of life is now threatened by the accelerating pace of climate change, is a microcosm of a global crisis. The rising temperatures that are making an already extreme environment even more dangerous are a direct consequence of a warming planet. The Danakil, the hottest place on Earth, is becoming a front line in the battle against climate change, and the fate of the Afar is a stark warning for vulnerable communities everywhere. Their struggle highlights a profound and uncomfortable truth. Those who have contributed the least to the problem of climate change are often the first and most severely affected by its consequences. The Afar salt miners, with their carbon-neutral existence of manual labor and camel caravans, are facing an existential threat from a phenomenon driven by the industrial emissions of nations thousands of miles away. Their story is a powerful call to action, a plea for climate justice from the very edge of human endurance. It transforms the Danakil from a place of geological and biological study into a site of urgent social and ethical importance. Furthermore, the scientific discoveries in the Danakil compel us to act as responsible stewards, not just of our planet's familiar ecosystems, but of its hidden ones as well. The unique extremophiles that live here are a priceless biological treasure. They hold the secrets to the origins of life, the potential for new biotechnological applications, and the keys to our search for life elsewhere in the universe. Yet this unique environment is fragile. Unregulated tourism, pollution, and even the effects of climate change could irreversibly damage these delicate hydrothermal systems, destroying a library of genetic information before we have even had a chance to read it. The Danakil Depression, therefore, is not just a place to marvel at. It is a place to protect. It is a World Heritage Site of global significance, a natural laboratory that belongs to all of humanity. Its future depends on our ability to balance the needs of scientific research, the development of sustainable tourism, the rights and survival of the local Afar people, and the overarching need to address the global climate crisis. The Danakil is a test. It asks whether we are capable of appreciating and preserving a place that is not just beautiful, but also difficult, dangerous, and profoundly strange. So the next time you gaze up at the night sky and wonder about the possibility of alien worlds, remember the Danakil Depression. Remember that you do not have to leave our own planet to find a landscape that defies imagination. A place where the ground boils, the air burns, and the colors seem to be borrowed from a surrealist's dream. We live on a planet of infinite variety and astonishing strangeness, a world that still holds deep mysteries and profound wonders in its most remote and hidden corners. The greatest journey of exploration is not always outwards to the stars, but inwards to the undiscovered realms of our own Earth. The Danakil is more than just a destination. It is an invitation. It is an invitation to be humbled by the immense power and scale of geological time. It is an invitation to be astonished by the sheer tenacity and adaptability of life. It is an invitation to be moved by the resilience and dignity of the human spirit. It is an invitation to question our assumptions, to expand our definitions, and to see our world with fresh eyes. It challenges us to find beauty in the bizarre, to see order in the chaos, and to feel a sense of connection to the fundamental forces that shape our universe. In a world that is increasingly homogenized and predictable, places like the Danakil are essential. They are a shock to our senses and a tonic for our souls. They remind us that there is still magic and mystery left in the world, that there are still places that can inspire genuine awe, a feeling that is a mixture of terror and wonder. This feeling is a vital part of the human experience. It broadens our perspective, deepens our appreciation for the world around us, and inspires us to protect the incredible, fragile planet that is our only home. Let the story of the Danakil Depression be a reminder that our planet is a place of endless fascination. It is a world of fire and ice, of acid and salt, of impossible life and enduring humanity. It is a world that is far more complex, more creative, and more surprising than we can ever fully comprehend. And so, we are left with a final simple call to action. Keep exploring, keep questioning, and never ever lose your sense of wonder, because the greatest marvel in the universe might just be the ground beneath your feet. If you found this journey inspiring, don't forget to subscribe to our channel, share this video with fellow explorers, and check out our other adventures into Earth's most extraordinary places.